In this video we're going to be looking at density and how to use our density equation in order to calculate the density of regular shapes. So with density, our equation is density equals mass divided by volume. Now there are two different units that we tend to work with in science for density, and that's grams per centimetre cubed and kilograms per metre cubed. Now this kilograms per metre cubed is what we call the standard SI unit, so it's the one that materials will be quoted in data. So just like we typically use metres as our unit of distance, kilograms per metre cubed is our unit of density that we would normally use. However, when we're doing our experiments, a lot of the things that we measure in are in grams per centimetre cubed, and so we need to be able to convert between grams to kilograms and centimetre cubed to metre cubed. Now, hopefully going from grams to kilograms is more familiar to you, as it's the same as going from metres to kilometres. So in 1 kilogram we have 1,000 grams. So in order to go from grams to kilograms, what we've done is we have divided by 1,000. So 1,000 divided by 1,000 gives us 1. Whereas if we wanted to go from kilograms to grams, what we've done here is we've done 1 kilogram times 1,000 to get to grams. So if you can remember that 1,000 grams equals 1 kilogram, then you can convert. And you can also think, well, if I had 5 kilograms, how many grams is that going to be? Well, this 5 kilograms is 5 lots of that, therefore in grams it's going to be 5 times that as well, so 5,000. But actually what you've done is you've done 5 times 1,000 to get to your 5,000 grams. Meters cubed though, this is a little bit more tricky to get around, because 1 metre cubed is saying 1 metre times 1 metre times 1 metre, and 1 centimetre cubed is 1 centimetre times 1 centimetre times 1 centimetre, because remember, when we're talking about a cubed unit and volume, we're talking about doing our width times our length times our height. So A times B times C is our volume, and for 1 centimetre cube block, each of those would be 1 centimetre times 1 centimetre times 1 centimetre to give us 1 centimetre cubed. If it was a metre block, each of those sides would be 1 metre times 1 metre times 1 metre. So if we want to see what 1 centimetre cubed is in metres cubed, what we should do is convert our centimetres to metres. So 1 metre is 100 centimetres, sorry. Just trying to go the other way. So 100 centimetre is 1 metre, but if we then look at what these 1 centimetres are going to be worth, then 1 centimetre we have to divide by 100 to go from centimetres to metres. Then 1 centimetre is 0.01 metre. So then 1 centimetre cubed becomes 0.01 metres times 0.01 metres times 0.01 metres. And so then our answer in meters cubed is 0.0000001. So 1, 2, 3, 4, 5, 6 zeros and a 1. So that is our 1 centimetre cubed. So what this is a millionth. So going from centimetre cubed to meters cubed, we are dividing by 1 million. And therefore to go from meters cubed to centimetres cubed, we're having to times by a million. So this conversion and this conversion will be needed when you're answering that question 1 and question 3 of the worksheet. We could also write this in terms of 1 metre cubed, as if we times by a million, then we're getting a million centimetres cubed is equal to 1 metre cubed. So we've got 3 blocks here which are all of the same volume. However, as you can see, they all have a different mass. So the plasticine 100 grams, steel 162 grams and iron 298 grams. So our first step that we need to do is going to be calculating our volume. So on this slide we've been given our volume, our base, our width and our height, so 12, 4 and 3. So we can use those in order to calculate our volume in centimetres cubed. And then what I'd like us to do is to calculate the density of each of those blocks. So I'm going to swap to visualizer so that I can show you how to calculate the density of the iron block, and also how you could tackle the extension by doing it in kilograms per metre cubed as well as grams per centimetre cubed. So using those unit conversions that we've just looked at. Okay, so for our iron block, we've been told that we have mass of 298 grams and we've been given our dimensions of our block in centimetres. So the first thing we need to do is we need to be able to calculate our volume so that we can then calculate our density in grams per centimetre cubed. So for our volume, we're doing our base times the width times the height. So 12 centimetres times 4 centimetres times 3 centimetres and that comes out to be 144 centimetres cubed. So then to get our density as grams per centimetre cubed, we need to do 298 grams divided by 144 centimetres cubed. And that comes out to be 2.07 grams per centimetre cubed. For our extension, we could convert this into, we could calculate this in kilograms per metre cubed, so we need to convert our units. So remembering that 1 kilogram is 1,000 grams, so to go from grams kilograms, we have to divide by 1,000. So then 298 grams then becomes 0.298 kilograms. For our 1 meter cubed, that's equal to 1,000,000 centimeters cubed. So to go to meters cubed from centimeters cubed, we have to divide by 1,000,000. So we then have our 144 centimeters cubed. We have to divide by 1,000,000, 144 divided by 1, 1, 2, 3, 4, 5, 6 zeros. And that comes out to be 0.0000144 meters cubed. And so then our density in kilograms per meter cubed is going to be 0.298 kilograms divided by 0.0000144 meters cubed, and so that's 0.298 divided by 0.0000144, and that comes out to be 2,069 kilograms per meter cubed. Here we only had 3 significant figures, so that was our first, second and third. So for consistency we could keep that the same. Here at the moment we've got 1, 2, 3, 4 significant figures. So what we need to do is we need to round up that last one. So 2,070 kilograms per meter cubed to 3 significant figures. And this would be the value that if you looked up the density of iron, you would get it in grams per meter cubed, and so it's more comparable to the information that you could find online.